Welcome back to the Hydrogen Studies podcast, where we explore the latest research on molecular hydrogen and its potential impact on human health. Each week, we've been diving deep into different areas where hydrogen is showing promise, from cognitive health to aging. And today we're shifting our gears towards something that affects every single one of us, directly or indirectly: the heart. Heart disease remains the leading cause of death worldwide. Despite major advances in medicine, surgery, and public health initiatives, the number of people affected continues to climb. Cardiovascular conditions don't just impact individuals, they ripple out, affecting families, communities, and economies. But what if there are ways, complementary ways, to support heart health that we're only beginning to understand? Emerging research suggests that molecular hydrogen, the tiniest molecule in the universe, might have surprising effects on the biological systems that influence cardiovascular health. Now, let me be clear, we are not here to promote hydrogen as a miracle cure. Instead, we're going to take a balanced, curious look at what the science is currently telling us. From mitochondrial protection to endothelial health, we'll explore how hydrogen could potentially play a role in supporting our most vital organ. So grab your headphones, settle in, and let's dive into the science together. This is the Hydrogen Studies podcast, sponsored by Echo Water. Let's start with a sobering look at where things stand. According to the American Heart Association's 2025 Heart Disease and Stroke Statistics Report, cardiovascular disease is responsible for 1 in 4 deaths in the United States. That translates to more than 900,000 lives lost each year, a number that overshadows deaths from cancer, respiratory diseases, and accidents combined. What's even more concerning is that cardiovascular disease is no longer confined to older populations. More young and middle-aged adults are being diagnosed with conditions like hypertension, atherosclerosis, and heart failure earlier in life, influenced by a combination of lifestyle factors, environmental stressors, and genetic predisposition. Looking ahead, the situation appears even more daunting. In a 2024 presidential advisory from the AHA, researchers forecasted that by 2050, more than half of all adults in the United States will live with some form of cardiovascular disease. That's 184 million people, straining not only the healthcare systems, but also affecting workforce productivity, family structures, and national economies. The drivers of this surge are clear. Rising rates of obesity, diabetes, sedentary lifestyle, and high blood pressure are creating a perfect storm. And to that, an aging population and the cumulative damage of decades of oxidative stress and vascular wear and tear, and the burden becomes overwhelming. This grim outlook demands new solutions. While traditional interventions like medications, surgeries, and public health campaigns remain essential, researchers are also exploring adjunctive approaches. Therapies that might help slow the underlying biological processes contributing to cardiovascular decline. And this is where molecular hydrogen enters the conversation, not as a cure-all, and certainly not as a replacement for proven medical strategies, but as a potential adjunct, one that targets oxidative stress, mitochondrial health, endothelial function, and systemic inflammation, all root mechanisms at the heart of cardiovascular disease. The studies we'll explore today suggest that this tiny molecule could have a surprisingly wide-reaching influence on the major factors driving heart disease. Your body is a system, and when it's running right, you feel focused, energized, in flow. But sometimes we struggle to find that flow state. Why? Because there's too much static in our system: brain fog, fatigue, and inflammation. The Echo Flask clears the static by infusing your water with molecular hydrogen, a natural, science-backed gas that helps your body think sharper, recover faster, and run smoother. This is more than hydration. It's better focus, more energy, faster recovery, less internal stress, and long-term benefits that keep you sharp. When your water works harder, your whole system does too. Find your flow state with the Echo Flask hydrogen water bottle and get an unlimited supply of hydrogen water at home and on the go. Visit echowater.com and use code H2Studies to get 10% off of your first order with Echo Hydrogen Water products. One thing we know, at the cellular level, heart disease is deeply connected to oxidative stress and mitochondrial dysfunction. In a 2019 paper by Peoples and colleagues, researchers detailed how excessive oxidative stress damages mitochondria, the energy powerhouses of our cells, leading to impaired heart function over time. When mitochondria falter, the heart muscle doesn't get the energy it needs, and tissue damage builds. What's interesting is that molecular hydrogen, or H2, appears to interact with these same pathways. Studies like the one by Ghosh in 2020 showed that hydrogen water could support mitochondrial function in animal models, improving the activity of coenzyme Q, a critical part of the cell's energy machinery. Coenzyme Q is essential for efficient ATP production, and its decline is associated with heart failure and aging. In other words, healthier mitochondria may mean a more resilient heart. By protecting mitochondrial health and reducing oxidative stress, hydrogen may help maintain the energy balance that's so critical for cardiac function. Beyond the heart muscle itself, there's the vascular system, the arteries and veins that carry blood throughout our bodies. Endothelial cells line the inside of our blood vessels, and when these cells become damaged, it's one of the first steps towards atherosclerosis, the buildup of plaques that can lead to heart attacks and strokes. A 2016 study by Hara and colleagues found that molecular hydrogen could help reduce cellular senescence in endothelial cells. In simpler terms, it seemed to help keep blood vessels younger and more functional. Reducing senescence could mean better blood vessel elasticity, healthier blood flow, and lower risk of cardiovascular events. Similarly, a 2008 study by Osawa showed that hydrogen water consumption prevented the development of atherosclerosis in genetically susceptible mice. Less plaque, better blood flow, lower cardiovascular risk. Again, these are early findings, mostly preclinical, but they open up fascinating possibilities for protecting our vascular health. But what about real-world conditions like hypertension and heart failure? In 2020, Sugai and colleagues demonstrated that daily inhalation of hydrogen gas lowered blood pressure in a rat model of hypertension. Lower blood pressure reduces the strain placed on the heart, helping to prevent the cascade of damage that can occur when the heart must constantly work against elevated vascular resistance. By promoting vasodilation and reducing oxidative stress, hydrogen inhalation may offer a multifaceted approach to managing hypertension at its root causes, rather than just masking symptoms. Meanwhile, in the realm of chronic heart failure, Deragaina and her team in 2023 explored how hydrogen impacted the functional state of erythrocytes, our red blood cells, in rats with simulated heart failure. Healthy erythrocytes are essential because they're responsible for transporting oxygen to tissues, including the already stressed heart muscle. Deragaina's findings showed that hydrogen inhalation not only improved erythrocyte function, but also normalized several oxidative parameters, suggesting better blood flow and oxygen delivery to tissues. The significance of these improvements extends beyond simple oxygen transport. By improving erythrocyte function and reducing oxidative stress in the blood, hydrogen therapy could, in theory, help mitigate some of the systemic consequences of heart failure, such as fatigue, organ dysfunction, and further cardiac remodeling. Together, these animal studies hint that hydrogen might help support cardiovascular performance through multiple mechanisms, by maintaining healthy blood pressure, by enhancing red blood cell function, and by reducing the oxidative environment that exacerbates heart disease. While these findings are early, they point to hydrogen's potential not just as a supportive therapy, but as an agent that targets fundamental biological processes involved in heart failure and hypertension. Let's shift our focus now to the human research on hydrogen and cardiovascular health. Let's take a look. In a 2022 randomized placebo-controlled trial by Leo and colleagues, midlife and older adults with hypertension inhaled a low-dose hydrogen-oxygen mixture. The results? Participants experienced a significant reduction in blood pressure compared to the placebo group, suggesting real-world cardiovascular benefits. Similarly, in 2021, C and colleagues found that hydrogen acted as a supportive therapy for patients with unstable angina, a condition where reduced blood flow to the heart causes chest pain. Those who received hydrogen treatment alongside standard care saw improved outcomes compared to those receiving standard care alone. Further, in chronic heart failure patients, research by Deragaina and her team in both 2022 and 2023 indicated that hydrogen therapy reduced endothelial dysfunction and improved metabolic parameters in red blood cells. These improvements could have profound implications for heart failure management. And most recently, in 2024, G conducted a real-world observational study in China where patients using hydrogen inhalation as an add-on therapy for hypertension saw notable improvements in blood pressure control without any side effects. Altogether, these human studies provide cautious but exciting validation that hydrogen's cardiovascular benefits may not just be limited to laboratory models. So pulling it all together, molecular hydrogen seems to touch multiple aspects of heart health. It may help protect mitochondria. It may slow vascular aging. It may reduce the risk of atherosclerosis. It may support better blood pressure control. It may enhance red blood cell function. These are all pillars of cardiovascular wellness, and they suggest that hydrogen deserves a seat at the table as we search for ways to prevent and manage heart disease, alongside proven strategies like exercise, healthy diet, and stress management. But it's important to be clear, hydrogen isn't a silver bullet. It's a promising area of research, not a replacement for medical treatment. Next week, we'll be exploring hydrogen's role in recovery and athletic performance. How does this tiny molecule affect endurance, muscle soreness, and overall fitness? The early data is intriguing, and I can't wait to dive into it with you. Until then, take care of your heart. It's the engine that keeps everything else moving. And if you're curious to read the studies we mentioned today, you can find full references at hydrogenstudies.com. Thanks for listening, and as always, stay curious.